We are in the middle of the lesson on 4.2, and we are also going to start reviewing our unit circle properties for the unit circle quiz today. So what you really need to have out is worksheet 1 so we can finish it. Worksheet 2, side A, we need to do together as notes. Side B is homework. And then I don't think we're going to have much time to talk about worksheet 3 today. We're going to look at worksheet 4, which is just basically a unit circle practice thing, okay? So 1, 2, 4. Are we ready? We left off yesterday somewhere around here. Remember, the directions for these are really wonky because it says find the rotation in revolutions per minute if you're given the angular speed, and find the radius given the linear speed and the rate of rotation. So there's basically two totally different kinds of questions, and they put them in the same directions for some silly reason. I have no idea why. But they did it that way in the book, so I left it that way in the notes, so when you see it in the book, you weren't so confused. So for this first question, what are we given? What does that omega stand for? Yes, this is some kind of an angular velocity, okay? Only they want it in revolutions. Find the rotation, which is not, because we're changing it to revolutions, okay? It's no longer going to be an angular speed. But we're going to go 3 pi over 2, which we could change to a decimal, is radians per minute. And it says we want to change it to revolutions per minute. Oh, this is an easier one than yesterday. Didn't we have to change the units yesterday too? We just needed to change radians to revolutions. How do we do that? Okay, 2 pi radians. We're going to need that on the bottom though, right? And 1 revolution so that we can cancel the radians. And then we'll have revolutions per minute, which is what they want. So this was easier than the couple we did yesterday. If you're going to use your calculator and give me a decimal answer, got to remember parentheses because you're dividing by both the 2 and the pi. Are we okay with what I'm talking about? Otherwise, if you just type divided by 2 and then a pi, it's going to divide by the 2 and multiply by the pi because that's the order of operations. Otherwise, we could just do a little canceling here, and we should get 3/4 or 0.75. Is that what you got? Okay. And the answer was revolutions per minute, or RPMs. All right, starting with number 8, the directions change. It says we are to find the radius given the linear speed and the rate of rotation. And their rate of rotation is the second cousin to angular velocity. It means they're giving us an angular velocity but not in the right units. Okay? So we need to change this and make it into an angular velocity. But before we do that, what's the relationship? We're trying to find the radius, and we have the linear velocity and angular velocity. Anybody know that one? We have a V, we have an omega, we need an R. Omega times R, or W times R, is V, or linear velocity. We're trying to find R though, so what are we going to end up doing? Yep, we're going to use this. Okay? Now there's kind of a hot mess here because we have meters per second and revolutions per minute. So before we can divide, we need some kind of common unit, but we also need to change this to what? It doesn't become an omega or an angular velocity until it's in radians. So I gotta write kind of small because we need to do a couple conversions here. 120 revolutions per minute. How do we change it to radians? We multiply by 2 pi per revolution, which will get rid of revolutions. Okay, now it's in radians, but this is minutes, and this that we want to divide into is seconds. So can we change this to seconds while we're at it? What do we know? Yes, so we're going to put the 1 minute on the top though, right? Because we need the minute to cancel. That's really messy writing, I'm sorry. Okay, so the minutes cancel. So we have 120 times 2 times pi divided by 60, which is reduces to 4 pi, or about, somebody have it? This was 1 minute over 60 seconds. I'm sorry, it was really scratchy. And now we're down to radians per second. Four pi, or 12.6 radians per second, is our omega. What do we still have to do, guys? The linear divided by the angular will give us the radius. So 24.8 meters per second divided by 12.6 radians per second. The per seconds would divide out, and the radians, meters over radians, is just going to become what? Meters. Yeah, those magical units. The radius is how many meters? If I remember right, it's like 1.97 or something. You want to try the next one on your own, or not yet? Get started on number 9, see how far you can get. What should we use for our common units, maybe? Minutes? Because we want to divide it into this minutes, right? So I'm going to change this seconds to minutes. Are we totally lost? It's turning 3.6 times per second. Every one of those 3.6 times is 2 pi, so then we're to radians per second. But because we want to use this 118 feet per minute, I'm going to go ahead and change this to minutes. So 60 seconds will cancel the seconds and leave us with minutes. All right, I'm just going to go with a decimal, save ourselves some heartache, but it's a big number. Anybody else get 1357.2 radians per minute? Now what? Yep, 118 feet per minute divided by 1357.2, which is going to make this very small. Radians per minute will just give us a radius of how many feet? 0.087, depending how you round it along the way, I'm sure. Are we going too fast? You guys work on the next one. Make sure you do the typing. If you don't do any of the typing and you go home and you can't figure out why you're not getting these answers. Anybody get like 188.5 for the angular? And then we have linear divided by angular to give us radius. Don't forget that was dividing. I don't know why I wrote it that way, but I did. Anybody get an answer? Perfect. Somewhere around 1.36 inches. Good job. I heard somebody. Make sure we get that label in there. Now, number 11, there's some room for argument about what the meaning of this is. It says, curve on a highway has 1,000-foot radius with lanes that are 14 feet wide. We had a big discussion about whether that was 14 feet across each lane or 14 feet across both lanes. If it was a narrow street, 14 feet across both lanes would be okay, but I don't think a highway, 14 feet is like 3 of you guys laid end to end. I don't think you could get 2 cars passing at 60 miles an hour on a curve if you only have 14 feet. I know when it's in a little street in your neighborhood, they're probably only 14, 15, 16 feet, but just the little one lane, yeah. Because they argued with me that the whole thing was 14 less. I think it's supposed to be 28. All right, so on the okay, then I didn't read very closely earlier today, but it says how much longer is the outside edge of the far lane. So this arc way out here, okay, that's an arc length, right? This arc out here, we'll call that number 1. How much longer is that than the very inside here? Oh my goodness, if I could draw. That we'll call the second arc. Now, how do you find arc length? Okay, we know our R's, yes? For the inside one here, the radius is what? 1,000. What's the outside one? What did we just come to the conclusion? That the outside one has a radius of 1,028 feet. Okay, what's theta though? They want us to do a 180-degree turn though, so that would be just pi, right? So we're going to use pi radians. Yeah, they just did a 90-degree here, but it says if it's a 180-degree turn. Yep, you're right. All right, so for S1, the outside one, we'd have 1028 pi, right? And for the inside arc, we'd have 1,000 pi. Whoops, forgot a 0. And so how much further is it, or how much longer? 28 pi. Does that mean 28 feet? Now you got to multiply your 28 times pi, and we get what? Okay, round 88 feet further to go around the outside. Now remember, that was the very outside edge and the very inside edge. That's why those NASCAR guys want to hug the curve, right? Save a little bit of distance. All right, on the top of page 2, side A, we have one more concept, and then we're going to do some applications. We want to talk about the formula that deals with area of a sector. When you were in geometry, you did something like this. You took the number of degrees is a part of a circle, and then you multiplied by the area of a circle, yes? Does that sound familiar? Okay. To get the area inside this wedge or piece of the pie. That's if you're working in degrees. We're going to work in radians. And they develop a formula for you over here, but again, this is in radians. So we want 1/2 the radius squared times theta. 1/2 r squared theta will give us what? Yeah, the area inside here, okay? The theta has to be in radians. Oops, crossed it out. And our answer is going to be in whatever units r was in, right? Our label, if r was inches, then our area will be in square inches. Sorry, I'm not making much sense here. Let's try number 12. Jaden is planting a circular garden in her backyard. It has a radius of 10 feet as shown below. What area she want to make for tomatoes here? It would probably be easier to do this question in degrees if you know the formula, but we're going to be given the formula if we're using the reference sheet that uses radians. So we're going to use 0.5. What's our radius? 10 feet. And theta? 50 degrees times pi over 180. Now that reduces, but we're just going to type it in anyway. Can we just type 50 pi over 180? Be 5/18 pi if you really wanted to. About how many square feet of garden does she have? Or for tomatoes? Yep, 43.6 square feet, or around 44 square feet. Everybody okay? Now, I got this next one wrong on my answer key, I'm pretty sure. Because it says wildflowers. Anybody notice why it's a trick? You guys are so good. Yes, there's 2 of them. There's some here and some here. So if she does 80 degrees worth and 80 degrees worth over here, she's got 160 degrees. So we have 0.5 or 1/2 times 10 feet squared times 160 pi over 180. Yeah, I totally missed that there was 2 of them when I did my answer key. Bless you. Anybody get an answer? Yep, so somewhere around 140 square feet of wildflowers. Yes? No? Maybe? Okay, so if 6 ounces of wildflower seeds can cover 10 square feet of area, how many ounces of seeds does Jaden need to tell the little man at the hardware store or the seed store or the greenhouse? How many ounces of seed does she want to buy? Ideas?
82.
How'd you get that? Okay, so that's how many of these 10 square feet, and each one of those requires 6 ounces. If I was explaining this to my algebra kids, I would have said 6 ounces will cover 10 square feet. Therefore, how many ounces are needed for 139.6 square feet? What's that called? I'm going with a proportion, but yes, you would cross multiply and divide. Was that you, Seth? Is that a proportion? Oh. You win, Trey. So 84 roughly? Someone get that? 10 minutes ago when you told me the answer? Yeah, it's like 83.7 ounces, but I'm thinking she'd just buy 84 ounces of wildflower seeds.
Maybe like
Okay.
the guy that went to Subway with a ruler.
Yes. And honestly, I think when you'd probably need to change it to pounds, and it would tenths of a, the scales usually are in tenths of a pound or something these days. Okay. Or hundredths. Wind turbines. So we have a big old propeller looking thing on the top, and the length of one of the blades is 27.1. How does that relate to what we're doing? The blades are rotating 28.5 revolutions per minute. What is the angular speed and the linear speed to the nearest tenth? What is that? That 27.1 is a radius. Okay, which we don't need at all for the angular speed. Angular speed has to be in what units? Radians over time. Doesn't specify, so we can leave it in minutes. So 28.5 revolutions per minute becomes what if we change it to radians? We have to multiply by 2 pi, so what do we get? Okay, 57 pi or 179.1, if I believe Jenner, yes? And that's radians per minute. And that is the angular speed, guys. Which is a little w. All right, how do we find the linear speed? Okay, we have this guy. So we're going to take our 179.1 radians per minute and multiply it by our radius of 27.1 meters and get something whose label is what? 4800? I'm confused. Okay, gotcha. And that's label, guys? It's got to be a distance per time if it's a linear. Meters per minute. It didn't tell us in the question what we had to do, did it? Okay. Be careful because some of the questions are very specific about what units you need at the end. Like they could say, could have said change this to kilometers per hour or something. All right. Couple more quickly. Centrifuge in the high school lab, angular speed of, I got all excited. I was like, oh, they gave us radians per second. Yay. And then they, for some silly reason, want revolutions per minute. That's because usually they give us the RPMs, right? And they want the angular speed, and they're working backwards. Okay. So how do we change 400 pi radians per second to revolutions per minute? Dimensional analysis, help me out here. Okay. If you type that in, what do you have to be very, 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 very careful of? You need parentheses around your 2 pi. I personally would just cancel, right? 2 pi goes into 400 pi 200 times. So 200 times 60 is 12,000 RPM. Why do we need parentheses again? If we type this, what does the calculator do? Divide by 2 and then multiply by pi, because it thinks you want just use straight order of operations, which does it left to right. If you want it to divide by both of those, you need parentheses. Or you could push divide again. All right, what is the linear speed of a substance that is 8 centimeters away from the center? What is that telling us? 8 centimeters away from the center is? Okay, linear speed formula? Okay. Do we need this 1200? Remember they gave us the angular speed up here, and it doesn't say what units, so can we just leave it in seconds? 400 pi radians per second times what? 8 centimeters is 3200 pi, or around 10,000. What? Centimeters per second. Okay? So if a mosquito got caught on the very edge of the test tube before you put it in the centrifuge, he would be traveling 10,000 centimeters per second as he swirled around in the centrifuge. A very dizzy mosquito when he's done, right? Okay, a flywheel, some kind of thing that spins on a car. Flywheel mounted on an engine crankshaft has a radius of 6 inches. That seems important. If the engine is running at 2,800 RPMs, well, we finally know what that means, right? But for our purposes, we're going to need to do some converting. And in the final end, they want feet per second. Linear velocity in feet per second. Ideas? Yeah, it has to be in radians before we can use that formula. Yep, so 1 revolution is 2 pi radians. Then it's in radians, and then do you want to multiply by the radius? I don't care. We do it all at the same time. We don't have to. This would be 5,600 pi radians per minute. Now what? So V is that number, radians per minute times 6 inches. Unfortunately, we're still a long way from the answer because we have a lovely, ginormous 105,000, 557.5. I can't read that, it's a mess. Inches per minute. I'm going to move it over here anyway. 105,557.5 inches per minute. And what are we supposed to have? Just because they hate us, feet per second. So now what? 1 minute is 60 seconds. Well, good news is we get to divide and make that number smaller. What else? 12 inches is 1 foot. Oh, we get to divide by 12 as well. So you can do 60 times 12 and then divide, or you can divide by 60 and divide by 12. Just make sure both of those are in the denominator. Or you could put parentheses around 60 times 12 in the denominator. $146.6, anybody? Feet per second, just because they hated us and wanted us to convert for fun. All right. One more. Okay. We can do this. Angular velocity in degrees per minute and linear velocity in kilometers per hour. What do we know? 3.2 in diameter makes the radius 1.6. Do we need the radius for the angular velocity? No, and honestly, we're halfway there. They have 0.31 radians per second. It's, oh, look at this. They want it in degrees per minute. That's just wrong. Okay, what do you know about radians and degrees? Yeah, no. What's the conversion for radians to degrees? 180 over pi or 2 pi and 360, doesn't matter. So pi radians is equal to 180 degrees. Now we're in degrees, but they also want what? Minutes. So we need 60 seconds is a minute. So 0.31 times 180 times 60, and somewhere along the line we had to divide by a pi. I'm going to round to 1066 degrees per minute. Now that we didn't need that answer at all, we're supposed to find its linear velocity in kilometers per hour. .31 radians per second times what? Times the radius, which is 1.6 meters. 0.31 times 1.6 gives us a lovely 0.496. Label? Meters per second. I'd be happy, except it wants kilometers per hour. Okay, meters to kilometers. Who knows that one? 1,000 meters is 1 kilometer. Seconds to hours, that's a little bit trickier. Do we need to do seconds to minutes and minutes to hours, or you got it? 3,600 seconds in an hour. Seconds cancels, meters cancel. Anybody? 1.7856. All right, I'll round to 1.8. Label? Did we finally survive all the applications? Okay. I'm going to go ahead and let this run for a couple more minutes because I want to talk us through how we remember the unit circle. The units, this is worksheet 3 maybe? 4? Thanks, 4. I lied, 4. If you have trouble memorizing the unit circle, the part you're probably going to have the most trouble with is the ordered pairs, maybe. Okay? And there's a tricky method that uses your fingers for that, and I'm going to talk you through that. Okay? There's videos on it on YouTube, just memorizing the unit circle, and there's all kinds of different ways to help you memorize the unit circle if you want to watch some videos, okay? Let's fly through this real fast, though. Do you know how this goes? All of the, wait, we just want degrees. All of these are 30 apart, yes? Just clearly. Okay. Maybe not. Whoa. As long as I talk loud enough, you should be able to hear, and I can use this. Okay. All of these are 30 apart. So we can just go 30, 60, 90, 120. What's 30 more than that? 150, 180, 210, 240, 270, 300, 330, and 360. 40. We good? Got the degrees. What are the other ones? 45. The 45s. But be careful. The 45s start here too. So we have 0, 45, 90, 135, 180, 225, 270, and 315.
Fancy.
We good?
It's a British flag.
Okay. Now, I'm going to do the radians on the same one. There's another one on your paper if you want to do it on the radians. But since I have this one already color-coded, I'm going to use this. Because I'm going to count by those same red ones going around. 30 goes into 180 what? Pi over 6, right? Okay? So I'm just going to count my pi over 6. That's a pi over 6. This is 2 pi over 6's. This is 3 pi over 6's. This is 4 pi over 6's. This is 5 pi over 6's, which I'm going to go ahead and write out here because it doesn't reduce. This is 6 pi over 6's. This is 7 pi over 6's. This is 8 pi over 6's. 9 pi over 6's. 10 pi over 6's. 11 pi over 6's, and 12 pi over 6 or 2 pi. Now, do a whole bunch of those need to be reduced? Yes. 2 pi over 6 is what? Pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2/3. 5, 6. 6 pi over 6 is just pi. 8 pi over 6 would be 4/3 pi. 9 pi over 6, anybody? 3 pi over 2, 10, 6, or 5/3. Alright. Now I need to go back and do the what? The 45s. But remember the 45s also hit the 90s and those quadrants, right? So we had 0 pi over 4. Do you know how we got pi over 4? 180 divided by 4 is 45, right? Times pi over 180, yes, is it pi over 4? Or you can just memorize it. It's pi over 4. So that's the first one. Where's the second one though? This is 2 pi over 4s. Already got that one. This guy over here is 3 pi over 4s. 4 pi over 4s is 1. Got that guy. 5 pi over 4. 6 pi over 4. We already have him. 7 pi over 4. 8 pi over 4. 2 pi. That wasn't so bad? Okay. You're only going to have about 5 or 6 minutes to do the entire unit circle, including the ordered pairs and what's positive and what's negative. Degrees and radians, how we doing? That's pretty good? Okay. This is the part that freaks students out. Let me attempt to explain 5-figure thing, but it's not going to work very well on the video because you can't see my hand. Okay. Here's my hand. Left hand. I'll try to draw. Here's my left hand, okay, basically. This is my thumb right here. Because this is going to represent 0, 30, 45, 60, and 90. Okay, hold in my... I have a stubby little thumb that it's right there. There's my left hand. Got it? Okay. This is what you need to know. know. You know that? You're good. Because right now, this, if I fold this 0 finger in, I have 4 fingers above and none below. Okay? This one is, we'll reduce in a minute. If I fold this finger in, I have how many? 3 above and 1 below. If I fold this finger in, I have what? 2 above, 2 below. If I fold this finger in, I have 1 below, 1 above, 3 below, yes? Okay. 1 above, 3 below. Okay? If I fold this finger in, I have none above, 4 below. Now, does all that reduce? Almost. Square root of 4 is 2. 2 over 2 is 1. So this is just 1, 0. Does everybody knows that one, right? I hope so. Square root of 3. This was square root of 1 over 2, but square root of 1 is just 1, right? Square root of 2, square root of 2, square root of 1. This one should just be 1/2, and so on. All right, it's just supposed to help you if you have trouble with these, which one is 1/2 and square root of 3. I don't know if it helps anybody. I don't use it, I don't like it. Can I just finish? Okay. All I do, guys, I know there's just square root of 3 over 2 and a 1/2. Do you all already know that? I just got to make sure it's in the right spot, right? Okay. This is over and up. Which of those looks longer? The over or the up? If it's only 30 degrees up, it should be further over than it is up, right? Over, up. That was tricky. This one up here, is it further over or up? So it's over and up, because 1 is smaller than square root of 3, right? That's it. Now I got those right. I should be good for the whole unit circle. There's symmetry. These fold over, and it doesn't mean they flip. It just means it matches. This is exactly the same one, except what happened? I went left. This is the same one, but I went left. And then they fold down and they fold across. And all the 45s are just what? Yeah, square root of 2 over 2, square root of 2 over 2. Because the over and the up is the same when you have a 45, isn't it? It's isosceles triangle. Alright, I'm going to stop the recording, and then I want to see if someone can fill the whole unit circle in 5 minutes. Anybody think they can do it? You want to try it, Samantha?